All right, in this video, we are going to solve linear equations with a variable on both sides. In regular math 7, we only solved equations with variable on one side, so these are just a little bit more difficult. For this video, you need 1.1 video sheet and a pencil. All right, so what I want you to do first is to go ahead and solve this as a review on your own. Go ahead and try to solve this one and see if you can remember how to distribute and how to solve a two-step equation. So pause the video and do that, please. All right, if you're back, hopefully you were able to make some progress on your own, but if not, this is a quick review. To distribute, you're going to multiply 5 times both of these expressions inside the parentheses like that. And then to solve this equation, hopefully you remember that you're going to add 15 to both sides first, and then divide by 10. Now, in your regular Math 7 class, you would write this as 2 1/5. 2 2/10 or 2 1/5. Going forward, your teacher is going to be okay with you reducing this to 11/5 and leaving it. It's actually considered slightly preferred to leave it going forward in algebra. So kind of forget what you learned. No, don't forget it, but don't worry as much about changing things to mixed numbers. It's still going to be acceptable to do that, but you might as well leave it like this. That's going to be perfectly fine to leave it in improper fraction form as long as you reduce it, just so that you know that. All right, this next slide is not on your not in your video sheet. So I'm going to quickly recall this balanced model. If I was trying to solve for x, which is this green block here, the first step in this equation would be to subtract 3 from both sides. So this is the balanced model that you've probably seen before. As an equation, it looks like this: 2x plus 3 equals 7. And that's why we subtract 3 from both sides, because we're dropping 3 off the balance. And that gives you 2x equals 4, which you look at the visual, 2x equals 4 right now. And that's why we divide by 2 to find the value of x to just be 2. All right, so I want to go and look at what happens when we have variables on both sides. So if you look at this balance model, again, this is not on your video sheet. This would be 4x plus 6 equals 2x plus a lot. That's 18. So I want you to think about what you would do, or maybe even pause the video and try to get the value of x by just walking yourself through this balance model. You might be able to get it, you might not, but it's a good challenge to try it. So pause the video and try to get the value of x right now. All right, so if you look back at the balance, it kind of makes sense that we can do this first. We're gonna drop 2 x's from both sides and keep that balance balanced. So that would be the first step. And if I show you this in the equation form, it would look like this. I'm going to subtract 2x from both sides, and that's always the first step I want you to do, is get the x's so that there's only x's on one side. That way you will be able to solve it, because we know how to solve an equation that looks like this already. We just did it on the last slide. All right, so your first step is going to be to get the x's on one side only. And if you look at the balance model, it was by subtracting 2x from both sides. Now it's pretty easy to go forward. I can just subtract 6 from both sides. Okay, we do that. And then we have 2x equals the remaining 12. And x would be equal to 6. And I don't have room to show all that with algebraically down here, but that's visually what's going on. All right, so that's kind of how the balance model works for this. Going forward, we're not going to use the balance model, but I will show one more before we go back to your video sheet. So if you want to pause the video right now and solve this one for x, you can do that. All right, if you're back, I'm assuming you tried it. We subtract 1x from both sides. We subtract 4 from both sides. And then, so 2x equals 3. So x would equal 3/2. Or you could write it 1 1/2 each. That's how you would solve it. All right, so now we're going to go back to your video sheet, and we're going to do all these without the visual to help us. All right, so if you think you already know what to do, go ahead and pause the video and try it. All right, maybe you're back and you tried it, and you either got stuck or didn't. So we're going to subtract 4x from both sides first. That's going to get it down to a two-step equation that we're familiar with for Math 7. And you're going to subtract 5 from both sides, just like you would before. And that gives you negative 11, and you divide by 2, and your final answer is negative 11/2. So that's about what your work should look like for these problems. All right, now that you're getting the hang of it, try this one. All right, this time to get the inverse of negative 2 is to add 2x to both sides. So this one's a little bit different. So if that step gave you trouble, you could start over again and solve it from this point forward. And you're going to add 4 to both sides and divide by 5, and your final answer is going to be 1. All right, we'll go ahead and reduce 5 over 5 to 1. Final answer is 1. All right, so we just have a few more for you to try. Now that you get the hang of it, hopefully this is starting to make sense. Now in this problem, and like all problems, we actually have two choices. We could add 3x or we could add 11x. It doesn't really matter what you do. I'm going to add 11x. I like to stay in the habit of keeping the x term positive, but you could just as easily add 3x to both sides, and this would work as well. All right, so that gives me 8x plus 30. I subtract 30 from both sides, and that gives me negative 54. And you divide by 8, and that gives you negative 54 over 8, which happens to be, well, we can reduce it. Divide by 2, and you get negative 27 over 4. And that answer is perfectly fine. If you want to change this negative 6 3/4, you can do that as well. All right, the home stretch. I believe this might be the last problem if I remember correctly. All right, so go ahead and try this one. Pause it and come back. If you're back, I'm assuming you tried it. Don't be lazy on me now. All right, so you distribute first, subtract 6x from both sides, and then you're going to subtract 12 down here and divide by 3. Notice how most of these aren't working out to be very nice, and that's okay. Negative 22/3 is perfectly fine. You can change it to negative 7 1/3 if you want to. And I think that was it, right? No, there's one more. I forgot this guy. All right, this is the doozy. If you can do this, you can handle any situation. So distribute first. Be careful on this one. This one's hard. Pause the video, come back. All right, I am getting negative 6x. Here's the tricky part right here, plus 2. All right, a lot of kids mess up right here. Now, you can't subtract 4 minus 3 and get 1. It's also a common mistake. Multiplication comes first. So you have to distribute. Now, we haven't seen this come up yet. I would wait at this point and don't start solving until you've made the equation look a little prettier by simplifying. So I'm going to make this right side a little nicer by combining like terms. So negative 4 minus 15 is negative 11. That's a really important step. Now I'm going to add 6x to both sides. I could add 3x to both sides and it would also work, but that gives me 3x minus 11. I add 11 to both sides. This problem has a lot of work, huh? And divide by 3. Final answer is 13/3. Again, you could change to 4 1/3 if you want to. All right, I hope this video helped learn how to solve equations with variables on both sides. If you need to go back and watch it again, print the sheet out again, work them, that should help. All right, ignore that. All right, we'll see you next time.